Hello again, and we are looking at graphing pairs of linear equations and or inequalities. So we're looking at doing this. The way our goal is how to graph pairs of linear equations and inequalities. Just as kind of a way of introduction, this is the same as graphing a single equation or inequality. You just do it twice. So where the lines cross, and our answer is our answer set, just like what we talked about with substitution and elimination with pairs of linear equations. For inequalities, we kind of do the same. The area that satisfies both inequalities is the area that contains your answers. You'll see. Okay, so I know I just did, the most lame thing ever, but that's okay. You'll see, and I'm sure you're just as excited about it as I am, okay? So let's dive in. When given a system of linear equations, we can graph them to find our solution set. So we'll kind of do the same that we did before. We choose one red, one blue, and kind of even the same equation that we worked with from the beginning. See if you can pause a video and just graph these two on their own. Graph these two lines. I think you can do it. I believe in you, okay? And I believe that if you follow my instructions, and I believe that God is good, that you can definitely do this, okay? Pause the video and give it a try. All right, hopefully you did that and you have your own coordinate plane set up. That would be great. Okay, we're gonna see right here, we've got y equals 2x minus 4. Our slope is 2 over 1. Our y-intercept is -4. So we're changing some of the colors here just to, make sure you understand what's going on. Make sure you identify this, okay? And then the same here. So our slope is -2 over +1 and +4. So we've got kind of like equal, opposite, opposite equations here, you'll see. So if we graph this one, we've got our y-intercept -4, up 2 over 1, up 2 over 1. That's our slope. And we draw our line. This is the red equation, y equals 2x minus 4. This is the red line. Okay, the same for the other. We start at y-intercept of +4. We go down 2 over to the right one, down 2 over 1. And we have our blue line for our blue equation, y equals -2x plus 4. So our answer set is where those two lines cross. Our answer set is right there. So it is +2 on the x. I know it's kind of blurry, kind of covered. So +2 on the x line, 1, 2, and 0 on the y line. Okay, you can see right here, it's 0 on the y line. All right. Next question. We've got y equals -3 over 2x plus 2, and then y equals 2x plus 6. So same process as before. See if you can pause the video and answer this. Okay, I believe you can, so do it. If you have questions, it's okay to ask or go back and see how it's done after I do it or after it's on the screen, and then try again. That's okay, but I want you to try. All right, hopefully you did. Let's identify our slopes and our intercepts. So these are both in slope-intercept form, so we identify slope is -3 over 2, y-intercept is +2, slope is 2 over 1, y-intercept is +6. Let's graph those. So we start, y-intercept is 2, slope is -3 over 2, boom, 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 and we draw our line, okay? And we've got this right here. All right. We've got starts at y-intercept of +6. Slope is 2 over 1. So we can't really go off the chart up here. I mean, we could keep drawing extra lines. So let's just do the opposite. So instead of going up 2 over 1 to the right, we'll go down 2 and over 1 to the left, okay? Creates the same line if we do the opposite action. All right, and then we draw our line, and we have our answer set right there in the green circle. If you can see green, if you're not colorblind, okay? we're going to have -1 on the x-line. You can see it goes from -1 up here, and then 4, can barely see, kind of blurry covered, alright? 4 on the y-line. Alright, answer is -1, 4. Hopefully you were able to find that. If not, maybe go back and see, see if you can get it now. Alright, now we've got a couple of equations, some mixed up stuff. I want you to put it in y-intercept form, and then see if you can solve and graph them. Solve them by graphing. That's what I mean. Put it in y-intercept form, and then solve by graphing. Get the solution set. Alright, hopefully you did. And we got to get them in slope-intercept form. We switch some things around. I'm not going to go through the minutia or details of that. I'm sure you can figure that out. Y equals -2x plus 5. Then flip this around, y equals 3 over 2x minus 6. That one, just to make sure that you know what happened there, we had to get y by itself and then divide everything by 6. And then once we did that, we simplified, okay? So if you have questions about that, maybe go back and look. All right. We've got our two equations here. Maybe if you haven't done it from this point, at least you can graph it from here. I've given you everything you need to do it. At least try graphing it and finding your solution set by graphing. Okay. Giving you time to pause the video and hopefully do that if you haven't. So if we start with our red equation and our red line, we start at y-intercept of positive 5y. Our slope is -2 and 1, so we go down 2 over 1. We get our red line. Then we start here with our y-intercept of -6, and we have our slope of 3 over 2. We go up 3 over 2, up 3 over 2. We draw our line. And we get our solution set, which is 3 and -1.5. So 3 on the x-line, and then it's right there at about the halfway point for our line, okay? Right at about the halfway point. Okay. Now we are going to look at inequalities. So we've got inequalities. They're already in the slope-intercept form. So our inequalities here. Go ahead and we look at the same thing. This is the same set of equations just turned into inequalities from our first problem. So we will remember which area, or I'm sorry, remember what kind of line we set whenever it's greater than or less than, not greater than or equal to. Remember, it should be a dotted line. Let's go ahead and throw those lines up there. All right, so we're going to shade the area that satisfies the inequalities. So we've got these, we've got our lines set up. They're both dotted lines because they're both not equal to, greater than or equal to, or less than or equal to. We set this up, and now let's look at if we were going to shade in the area that satisfies y is greater than 2x minus 4. So remember our trick, wherever it crosses the y line, wherever this line crosses the y line, greater than would be above this. We could check that, but I'm not going to take the time to in this video. Less than would be below that, okay? So if we do greater than, it's going to be above there. So we fill in this area. It's not perfect, but you know, I'm trying here. Okay. This is the area that satisfies our first equation. All right. Then if we look at what satisfies our second equation, y is less than -2x minus 4, we see where does this line cross the y line? Crosses it right up here. Everything less than or below, not above for greater than, less than is below, is going to satisfy this equation. So this is the area that satisfies our second equation. So what we finally do is shade the area that satisfies both inequalities. So we shade in this area. This is the area that actually is our answer, our green. Remember, we're using green circles, green as our answer. This is our answer area right here that satisfies both these equations. This is just to show these areas do satisfy each individual equation, but this area satisfies both equations, so that any answer in this area would satisfy this pair of linear inequalities. Okay? That's the way that we get this. We shade both sides, and then once we see what overlaps, that's our answer area. All right, so let's try another one. It's already in slope-intercept form, so I think you guys can do this. All right, work it out, graph it, and see that you can get the answer. Shade in the area that satisfies both equations. Try to do it on your own. Okay, maybe I'll give you a little bit of an introduction here, and hopefully you can get it from there. I'll kind of go step by step. Maybe pause if you see that, okay, I got it now, I can do this. Pause it and then go and do it. That would be fine. All right, I'll throw the lines up there. So if we've got y is greater than or equal to 2x minus 4, slope is 2 over 1, y-intercept is negative 4. We start at negative 4 down here. We go up 2 over 1, up 2 over 1, we get our red line. Y is greater than 4x minus 6. Hey, so our y-intercept is negative 6, our slope is 4 over 1. We start at negative 6, we go up 4 over 1, up 4 over 1, get our blue line, and now let's shade the areas that satisfy our inequalities. So when we do that, we've got right here, y is less than or equal to 2x minus 4, less than or equal to, that's going to give us, from our trick where it crosses the y line, everything below that y line where it crosses there is going to satisfy this inequality. Okay, we could check that, but we're not going to take the time to. Then let's see what satisfies our second equation. Y is greater than 4x minus 6. Okay, second equation, greater than, we'll use our trick where it crosses this y line. Everything above that is going to satisfy our equation. So everything over here is going to be shaded in. And we're going to shade the area that satisfies both inequalities. So we'll bring those up. Okay, we've got this area that satisfies our blue equation, this area that satisfies our red equation, and this small slice is what satisfies both. And everything in this spot right here is going to satisfy both inequalities. So any answer within that little slice is going to satisfy it. And that's how we solve for pairs of linear inequalities or equations. So that's how we solve for that. Hopefully you understand pretty well now. If you have questions, go ahead and reach out to me if you'd like to. I love you guys. Have a great day.